Hi, I'm Ray from the Radial workshop. Call sign is G4NSJ. Vertical aerials. I talked about doublets, horizontal type dipole aerials. And let's just have a little look at verticals. What's the difference? Basically, a horizontal aerial, such as a doublet, a dipole, doesn't matter how it's fed, coax, ribbon feeder, whatever. Basically, that's pretty good for sort of skywave up and down. So for example, if I'm chatting on 40 metres and I want to chat to people in the UK where I am, I'm best on some sort of dipole, some sort of horizontal aerial, because that way I'm sending out the RF up to the ionosphere, bounces back down in, for example, Sheffield, London, Nottingham, Wales, Scotland. So I'm covering the UK nicely with that. A vertical aerial, such as a pole, that is going to send RF. It'll send a little bit up that way, yes, but not a lot. Most of it goes off at a low angle like that. Now, quite some time ago this was, but I was chatting to an amateur in Cornwall. I'm in Worthing on the Sussex coast near Brighton. He's in Cornwall. I'm on my horizontal doublet. And we're chatting to him, and I said, look, I'm just going to switch over to my vertical pole. I've got a 40-foot pole that I made up. Show you a picture in a minute. And I've got a separate ATU for that. I'll explain all that in a minute. So I switched over to the vertical. He could hardly hear me, and I could hardly hear him. So I went back on the doublet, and he said, I'm afraid your vertical aerials are absolutely useless. I could hardly hear you. So anyway, I left it at that. I thought, no, it's not useless at all. It's not useless. What was happening was I was firing my RF off at a low angle. So here he is in Cornwall, here's me. I fired a signal like that. It goes over his head, up to the ionosphere, glances off that, back down in America. Now, I did prove this that evening. The band was open, there's a lot of stations. On the horizontal, I could hear all the UK stations. On the vertical, I could hear American stations. And I switched between aerials, and it really was good. On the vertical, UK stations, no good. On the horizontal, they were excellent. And vice versa with America. So that proved the point. Not that it needed proving, but that did prove the point about, the vertical, the low angle of radiation, and that sort of thing. Right, I'm just going to show you a photo now, and I'll show you exactly what this 40-foot vertical I've got, what it's all about. Right, there's the pole. It's 40 feet. It's 20 feet is the bottom section of 2-inch aluminium tube. Next 10 feet is aluminium tube, I forget, but it's a bit thinner, and that's bolted, that goes into the pole at the top, and that's bolted there. Then the extra 10 feet on the very top, I'm taking up to 40 feet, is a fiberglass rod, and there's a wire connected to that rod which goes up. That gives me sort of electrically a 40-foot conductor. So that's that. This is the experimental stage. This is the base at the moment, just resting on a piece of wood here. There's the ATU. That's an L match. Okay, so it's just a little roller coaster and a variable capacitor. I'll talk a bit more about that in a minute. So yeah, this is the experimental stage. It's actually, the pole is actually, there's a bracket onto a fence post up at about 6 feet, and there's the guy ropes, of course, so it's all pretty good even in the wind. Have a look at this photo here. This is a railway insulator. This is a little bit later on. This holds, down in the south here in the UK, we've got the third rail system, the conductor rail. This is an insulator. The conductor rail sits in that. You've probably seen them. And what I've done is drill a hole each side in the upright plates that where the rail would normally fit in there. Drilled a hole each side, and I've put a rod through the holes, the base of the aerial, a nut on each, on the outside, and on the end of the rod. Nut each end, so you can actually lower the aerial down. It's pivoted, and that's quite a good system. And that acts as an absolutely brilliant insulator. is a good base for the pole, and that insulator is pretty strong, bearing in mind it has to support the conductor rail, you know. So there we are, that's that. Now I actually I'm going to show you another picture in a minute. That's the aerial itself, that's what it looks like. So what I'm now going to talk about is using this aerial on 20 meters. It works on 40, as I've said, but let's talk about now using it on 20. Just before I talk about using that 40-foot pole on 20 meters, blimey, it's pouring with rain now. Great, it's the end of the sunshine. The idea of that insulator at the bottom, you know, is obviously to insulate it from the ground. It's good for that. It also acts as a pivot. So when we get high winds like we've had this winter, all I've got to do is release the clamp on the fence post, undo the guy ropes, and that pole will just go down like that. And I just put it along the garden path, all 40 feet of it. You know, you can also do maintenance on the pole where the joints are and things like that. Also, the top of it, I've got an insulator that supports one end of my doublet, one end of the wire of the 98-foot doublet. So it's not just an aerial in itself, it's also a supporting mast for the end of the wire. So okay, using this on 20 meters, now on 40 meters, as we've been talking about, I think it's about a quarter wave. You can work this out. Well, it's 40 meters, so 20 meters would be a half wave. On 40 meters, 10 meters is a quarter wave, 10 meters high. So what's that, 30 something feet, getting on for 40 feet. So it's about a quarter wave. The trouble is with a quarter wave, as you probably know from like a 2 meter mobile aerial, if you've got one on your car, the trouble is with that, you've got all the current at the bottom, right, and the current tails off towards the top, which the current will anyway. It'll always be, it's always high voltage at the end of a wire or any aerial. The high voltage, no current, is always at the end, the free end. So what we want to do, if you have a look at this, right, there we are. This is the 40-foot pole, all right. And you can see the curvy line, that's the current. Now it's the RF current that we want. That's what puts out the signal, not the voltage. It's the current. We want to get the current up the pole. Now bear in mind we're talking about 20 meters now, the 20 meter amateur band, all right, 14 megs. I've worked this out. The 40-foot pole is a 5/8 wave on 20 meters, on 14 megs. Now, being a 5/8 wave, again, as you might know from 2 meter aerials, a 5/8 whip for 2 meters for your car is a damn sight better than a quarter wave whip, because you get the current up higher. And you can see from this diagram, this picture here, that the current, there's a little bit of current at the bottom there, but the main sort of maximum part of the current is up higher, up much higher, not all down near the ground as it would be with a quarter wave. So this is an ideal aerial for 20 meters. I mean, I didn't work out, oh, I need 40 feet. I just put up a 40-foot pole, and it was afterwards I started thinking, you know, should I use this as some form of vertical? So, okay, that's that bit. You've seen that diagram. We'll now move on. Right, one thing I must mention, with any vertical aerial like this, you will need radials. Basically as many bits of wire on or under the ground, all fanning out from the base of the aerial. I can't fan them out because mine's at the end of the garden, so I can only obviously put them in the garden itself, not all round. I've got under the lawn, I've got chicken wire connected to it. Just have lots of wires, as long as you can get fanning out under the lawn, chicken wire, whatever. You'll need that. Right, connecting the aerial. Okay, I'm going to show you a picture of the little ATU I built in a minute, the circuit of that. Basically, I've mentioned this in previous videos. If you connect the inner of the coax to the base of the pole, the outer of the coax to your earth system, all your radials and everything, your chicken wire and that, that's all very well. What you will have to do is alter the height of the aerial to get the SWR right. Back in the shack, in the house, the shed, wherever you are, adjust the height, the length of the aerial to get the SWR down to 1:1. Now, That's not going to be very practical. Well, I suppose you could do it. You've got to lower the aerial, take a bit off, put it back up, all that palaver. Best thing is what I've done is an ATU at the bottom of the aerial. In fact, the ultimate is an automatic ATU at the base of the aerial. Okay, the pole connected to the aerial terminal, your earth system connected to the earth terminal, and then the coax right away into the house, wherever your radio is. That way you've got an automatic ATU at the base of the aerial. Whichever band you're on, it'll load it up for you. Brilliant. But I'm not I'm not one for spending money on automatic ATUs when I can knock up a little one for nothing, a little manual one. So this is the circuit. I'll have a look at this. Here we are. This is the circuit of the ATU. I've put there the radials here. You want as many as you can, all coming out all around the place. That's a double capacitor out of an old vintage radio. Right, just join the two together. Gives you about 500 puff. The coil, it depends what frequency you're on. Wind a coil. This is a little roller coaster I found in the junk box, which is quite good. So yeah, just some kind of coil. It's an L match. That's all you need, is an L match for this sort of aerial. Again, a bit of a palaver. You've got to go in the house, check the SWR, come back out, adjust the ATU, blah blah blah. What I did, I put the SWR meter, the coax went into that at the base of the aerial, coax into the SWR meter, out of the SWR meter into the ATU. Okay, I went and put a carrier on the transmitter, 5 watts carrier, come out, load up the aerial with the ATU for minimum SWR, then take the meter out of line, blah blah blah. You see what I mean? Okay, that's a look at that. Right, the thing is, that is then only going to work on one band, unless each time you come out and adjust the ATU, which is going to be, well, it's too much of a fuss. You can't do that, come and load up all that business every time. What I did, I built the whole lot in a plastic box with the SWR meter, viewable through like a plastic window, left it in there permanently. So, and I had sort of preset markings on the controls of the ATU, the roller coaster and the capacitor, and I sort of did presets for, I don't know, 2 or 3 bands, something like that, which was okay. But I know ideally, as I say, you want an automatic ATU for this sort of thing, or use it, set it up on one band, or another idea, which I never did do, it might be an idea, build sort of separate ATUs for each band. You don't have to have just a coil, just wind a coil and a capacitor specifically for each band. But there we are. What you do with it is up to you. Obviously, how you mount the pole on an insulator is up to you. I found the conductor rail insulator worked very well for me, especially as I can pivot the aerial. So you've got to have all these radials going out everywhere for your kind of earth system. You'll need an ATU at the base of it, or ideally, if your shack is a shed at the end of the garden, you could just bring a wire straight in from the bottom of the pole, straight in through into the shed, into an ATU there, next to your radio. All right, that little bit of wire will be part of the aerial, but that doesn't matter. Okay, so that's the ATU, and that's the radials. So let's move on again. I've just noticed on the circuit of the ATU, I've marked radials there, 16 feet long. Ignore that, that was for something else. Basically, just as many as you can and as long as you can. Just fill all the land you've got with radials and chicken wire and whatever. Right, what else? I made a couple of notes here because I forget things. It's old age. I did try that on, hang on, let's turn this down. It's 2 meters bursting into life. Good grief, not calling me. No one ever does. Anyway, where was I? 80. I've tried it on 80 meters. Now the thing is, on 80, yes, you can load it up if your ATU's man enough, or got a sort of wide enough capabilities of loading anything. But the trouble is, on 80, that the thing's only about a 1/8 wave. I can't work it out off in my head, but it's about 1/8 wave, which isn't, that's no good. I want to come on to another aerial in a minute that I made for 18 megs. That's the 17 metre amateur band, I forget. Come on to that in a minute. Oh, here's another view of the whole aerial. Just have a look at this. This is quite good. There we are, protruding, what is it, majestically from the trees and heading skyward and all that nonsense. Actually, those trees didn't really affect it. They're not as high. They were small plum trees, so they're not as high as they look. But that's another view of the aerial. Blue sky. Okay. So yeah, as I say, you could use this on one band. I used it successfully on 20 meters. That's what I found it was really good on, because it's a 5/8 wave, good low angle of radiation. You got the current high up, and I worked all over. Well, you know, the Middle East and all around the place. America on 20 meters. You know, it was easy, really good. And I did comparisons with the you know, the doublet, the horizontal aerial as well. Now let's just look at another aerial that I knocked up. This is a vertical again. I'll just get to show you the pictures of this one. Hang on a sec. Unfortunately, I haven't got a picture of the whole aerial, but this is the base. Right, what it is, that's an insulator, as you can see. This is a one band aerial for 18 megs, the 17 metre amateur band. It's made out of 22mm copper pipe. Well, I forget the length. It was a quarter wave for 18 megs. What was it, about 14 feet? Can't remember. You can work that out. There's a picture here, look, of an ATU in the bushes. That wasn't for this, because this one didn't use an ATU. I don't know what that was for. I remember my wife, you know, she used to do a bit of gardening, and she'd come across cables and coax and earth stakes and ATUs in plastic boxes. Definitely. I forget what that one was for, but that worked well. I remember that plastic box. Anyway, back to the aerial. Okay, so it was basically 22mm copper pipe. I think 14 feet or whatever. I used copper pipe because it was, the 22mm was quite sturdy, it doesn't bend. Don't know where I found the insulator from. Loads of radials out from that, and what I did was I adjusted the length of it to get the SWR right back in the house where the radio was. So all I had to do, I remember, was stand on a step ladder. I had a little telescopic bit at the top, and that was brilliant on 18 megs. There were some locals that used to have a sort of cross-town chat on 18 megs, and I joined in with them. And it was one day we were just chatting. I think just one friend of mine and myself were having a chat, only running like 10 watts, something like that. And a chap from Israel joined. Was it Israel? Somewhere down there. He joined in. And I thought, oh, this is amazing. You know, this is working well. And he gave me a far better report on my little copper pipe vertical, the quarter wave ground mounted vertical, than he did my friend, who had a, you know, dipole up at whatever feet, doublet or whatever, end fed wire I think he had. So that's something else you can knock up. It's dead easy, and none of these aerials cost any. Well, apart from the, you know, the 20-foot 2-inch aluminium tube, that sort of thing, a bit of copper pipe. But you know, you're not spending a fortune on sort of ready-made aerials. Some of these verticals, they reckon they cover all bands from 80 and that. How can it cover 80 metres? Some of them are only about 20 feet high. You know, it's a sort of a 16th wave on 80, full of loading coils. It might be right for chatting across town, but no, I like building my own aerials. Also, you don't need like hundreds of feet of garden for the verticals. You just need a little bit. Well, you want to get your radials out, of course, but somewhere where you can just stick up a pole. So yeah, that's my my 17 metre amateur band quarter wave ground mounted vertical. No ATU, coax straight from the bottom, between, you know, inner to the copper pipe, outer to your radials. Run it into the house, straight into your radio. Bob's your uncle yet again, whoever Bob is. I think that's about it. I think I've covered everything. No doubt people will comment, say, oh, you didn't mention this, you didn't mention that. Oh well, there we are. Hard luck. My wife, yeah, and the gardening. She still does a bit of gardening, so do I, but there aren't ATUs and stuff hidden in bushes anymore. I've sorted all that out, made it all neater. Right, what else have I written here? What I did what I've done, the coax from the the ATU at the base goes to the house. What I've done is bury it under the ground, gets it out of the way. Doesn't look unsightly, so I don't get into trouble. But also the biggest thing is any RF on the outside of the coax, which there shouldn't be anyway, but that's all decoupled to earth under the ground, so the ground acts as like a big RF choke, if you like. So when you eventually get it in the house, then it's not radiating at all. Not that it should do anyway. Okay, that's my notes. So yeah, just remember that you want to listen to America or far away countries, or not just listen to, work them. They're going to come in at low angles. All right, their signal's going to come off the ionosphere at a low angle like that. So your vertical is best for that. And when you transmit, I mean, there will be skywave when you transmit from a vertical, but not a lot. Most of it is this way. That's why on, for example, the CB band, the verticals, everyone uses a vertical because you've got ground wave. Plus, you're okay for covering the local town, which is what it was all about originally. But for people who want to work a bit of DX when the band opens, they've got low angle because they've got a vertical. A beam, of course, you are firing that way anyway, so you've still got the low angle if you're lucky enough to have a big HF beam. But I'm talking about inexpensive aerials that you can knock up yourself in your back garden. You're not going to go and buy a tower and a beam and a rotator and all hundreds of pounds. I don't know why my phone keeps making noise, dings and and things. Right, that's that. Yes, there's I don't know whether you've heard of NVIS, near vertical incidence skywave, firing signals straight up. I've done some experiments with this on the 5 meg military frequencies that were allowed to go on in the UK and some other countries. I had a dipole 6 foot above the ground, 5 meg dipole. That was coax fed because it was experimental, one band. Only 6 foot off the ground. The nearer to the ground it is, the more the skywave is going to go up. The idea of sending it almost vertically up is, right, you want to talk to someone on the other side of some hills, say a mountain. All right, you're not going to do it on VHF or UHF. You won't get through the mountain. It won't go over the top. So what you do on 5 megs, is it 5.3, whatever the frequencies are, you have a very low aerial, low dipole or whatever, and that will fire your signal straight up to the ionosphere and straight back down just the other side of the hill or the mountain. Okay, if you've got a vertical, you're going to fire it off at a low angle. They won't hear it the other side of the mountain. And this, just out of interest, is why on some military vehicles you'll see the aerial is like, instead of being upright, they hook it down for when they're driving along. They also hook it down to make it horizontal instead of vertical, so they can have a chat the other side of the mountain. There we are. Not many people know that. Okay, is that it? Yeah, I think that's about it. So there's probably loads more to say, but it's good fun. Experimenting with aerials is good fun. None of it's difficult. I remember there's one chap, just mention this, then I really will leave you in peace. I'll disappear. One chap, he went into all the mathematics, working out a formula for this, a formula for that, and he put up this aerial, and it was useless. I don't know what he'd done. There was a local chap. He was always full of mathematics, and he had a calculator, square of this and that multiplied by that. And there's other people, one in particular, he chucked up an aerial, bit of wire, over the garage compound from his window, down there to the tree, back to that washing line post there, up to the gutter, round the bend, up the wall, and he used that aerial, and it was absolutely brilliant. He got the right length of wire in the right configuration at the right time, and it was brilliant. That was for top band, I think. Absolutely brilliant. Knocked spots off everyone else's aerial. So experiment, it's good fun. I really will go now. Thanks for watching. Bye bye.